Looking at example 3 here, once again we're still working in section 4.4 and going through definite integrals. We notice we have the integral from 1 to 4 of 3 times the square root of x dx. Okay, I'm going to walk you through this one a little bit. It's just rewriting, and like I said, this entire section is being able to evaluate definite integrals, so being able to take that antiderivative is very important. So in this scenario, for us, rewrite that square root of x as x to the 1/2. Now it's much easier for us to take the antiderivative, right, because it's x to the n plus 1 over n plus 1. Keeping that 3, we can factor that 3 out in front, and when we take the antiderivative, we end up getting 3x to the 3/2 over 3/2. Remember, we don't really want to leave it in that form. It's okay if you're evaluating, but for simplicity reasons, alright, we're going to multiply by the reciprocal of that fraction in the denominator to clear things up. So we're going to multiply the numerator and the denominator by 2/3. Okay, so when we get our final simplified antiderivative, we're going to end up with 2x to the 3/2. Alright, because on the bottom everything goes to 1, and then the 3 with the 2/3 cancels with the 3. So we're just left with that 2x to the 3/2. Now, we go back and we evaluate that. So we have 2x to the 3/2 evaluated from 1 to 4. And that's how we write, that it's being evaluated. So we always evaluate the upper limit, which is 4, and we're substituting that into x. So it's 2 times 4 to the 3/2 minus 2 times 1 to the 3/2, 1 being the lower limit. So we get the numerical value. So 2 times 4 to the 3/2 is 16, and 2 times 1 to the 3/2 is obviously 2, so 16 minus 2 is 14. Let's take a look at the next integral now, everybody's favorite when we get into trig functions. Okay, so in this case, we're taking the integral from 0 to pi over 4 of secant squared x dx. First step, always find the antiderivative. There's nothing to factor out here, so we're going to find the antiderivative. And you can look at the inside cover of the books, those 4 pages, that handout that I made for you guys. This one will be listed on there too. Make sure that you start learning these antiderivatives of trig functions by heart. Okay, but the antiderivative of secant squared x is tangent x, right? If we take the derivative of tangent, we get secant squared. So we've got to be able to go both directions. So we're going to evaluate tangent of x from 0 to pi over 4. Okay, so upper limit minus the lower limit. So in this case, tangent of pi over 4 ends up being 1, and tangent of 0 ends up being 0. So we end up with 1 minus 0, which is 1. Alright, if you don't remember what tangent of pi over 4 is, and you don't want to draw the triangle 1 square root of 2 triangle, remember, if you use your calculator for this, make sure that your calculator is in radians mode, because pi over 4 is in radians. Okay, let's look at example 5 now. This one's a little different. Okay, there's ones like this on your homework, so make sure that we really pay attention. Remember, when we do anything with an absolute value function, there's always going to be 2 solutions associated with it. So example 5, we have the integral from 0 to 2 of the absolute value of 2x minus 1 dx. So there's 2 possible scenarios, right? There's a positive version and an opposite version, or what we're going to call a negative version. So we take that what's in that function, that 2x minus 1, we set it equal to 0, and we have negative quantity 2x minus 1. So notice the 2 possible solutions here. So what's that really mean for us? Both cases, the 0 ends up being at x equals 1/2. So I thought a good way for you guys to see this is for us to graph it. And we're going to look at the area under the shaded region, right? Because our limits of integration are 0 to 2. So when we graph this, okay, the vertex of that absolute value graph is at 1/2. And we want from 0 to 2. So we really need the integration of this small little triangle here and then this larger triangle. That's the area we're looking for from 0 to 2. So essentially we have to do this for every absolute value problem, because we're going to have to break it up based on where that 0 is. So there's 2 different integrations here. we're going to go from 0 to 1/2 of the negative of the function because we need that downward graph. Okay, so we're going to use the opposite there. So if you notice the integral here on the right hand side, we're going to take 0 to 2 of the absolute value of 2x minus 1 dx. We're going to rewrite it into its two different portions so that we get two of the positive values for the area. So the first integral is going to be 0 to 1/2. That's where the 0 is, of negative 2x minus 1. So it's going to get the area of the small triangle. Plus, we want to add we want to find the total area, so we're adding. We're going to go from 1/2 to 2 of the positive of that function, 2x minus 1. That's the hardest part on this problem. The next is doing what we've been doing. We're going to find the antiderivative of each function, evaluate it, combine them, and get our final answer. So, we take the two integrals from above and we get the antiderivative. Okay? Here, I distributed the negative sign. So notice up here, when we wrote this, it's negative is outside the parentheses, so negative quantity 2x minus 1. Distribute the negative through, so it ends up being negative 2x plus 1. So we did in this step right here. Then we take the antiderivative of each, so negative x squared plus x, evaluated from 0 to 1/2, plus x squared minus x from 1/2 to 2. Okay, so those are our two integrals. We're evaluating both of them. Then literally it's substituting in the numerical values. Separate things out with parentheses so that you can keep track of everything, and evaluating those values. And once you do that, make sure you guys work through this one maybe on your own. End up getting 5/2. Okay, so that's the total area that we would get there. Let's move on to the next equation. Okay, so on your homework, it's going to give you a blurb like this. It says, find the area of the region bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis and the vertical lines x equals 0 and x equal 2, and then it's going to give you this graph right here. So this is a graph of that function right here, this parabola. And notice we're limited on the x-axis from 0 to 2. So the vertical lines x equals 2 and x equals 0. So those are on our integral. That's our lower limit is 0. Our upper limit is 2 of this function here. So we really just have to set up the integral. So we're going to go from 0 to 2 of 2x squared minus 3x plus 2 dx. Now it's the same thing that we've been doing. We're going to take the antiderivative of that function and evaluate it at the upper limit and the lower limit. So we're going to substitute 2 into the antiderivative and 0 into the antiderivative. Okay, this should be starting to become a little easier for you. Notice anything where we got to plug in 0 most of the time, unless it's a trig function, that right hand side is going to go away. So substituting in 2, we get 16/3 minus 6, okay, plus 4 there, and then substituting in 0, all these terms become 0, so it's minus 0. So when you combine these terms, we're going to end up with 10/3. Alright, just doing some more practice on some basic integrals here. Nothing overwhelming. We're going to take the integral from 0 to 2 of 6x dx. Same thing, take the antiderivative. You guys did a lot of this in 4.1. The antiderivative of 6x is 3x squared, right? You're taking x to the n plus 1 over n plus 1. So the n on this guy, we don't see it as a 1, but 1 plus 1 is 2. Okay? And then divided by 2, so you're going to have 6x squared divided by 2. That's how we get the 3x squared here. We draw our line, we're going to evaluate it, so we substitute in 2 for x, minus, and then we substitute in 0 for x here, so you end up getting 12 minus 0, which is 12. This is very basic, no new learning on that one. Same with this example. We're going to go from negative 1 to 0 of 2x minus 1. Take the antiderivative of 2x, you get x squared. Antiderivative of negative 1 is x. We're going to evaluate that from negative 1 to 0. So 0 squared minus 0 minus, we're substituting in negative 1 here, negative 1 squared. Make sure you keep that negative 1 in parentheses so we don't lose track of signs, minus the negative 1 here. So negative 1 squared, this is a positive 1 here, and then negative times the negative makes this one positive here. So it's 0 minus. We can combine these inside the parentheses to get 2, and it ends up getting us a minus 2 because of this minus here. Okay. Now, same thing here. we're just using a different variable. Nothing special. Treat it like it's an x. Alright, we're going to go from negative 2 to negative 1 of u minus 1 over u squared du. It's okay that we're using u. We can treat it as x. We can treat it as what? We can treat it as whatever variable we want. So, for us, the best step to do on this one is rewrite that second part of the function here, that 1 over u squared. Write it as u to the negative 2. Much easier for you to take the antiderivative of. Okay? So basically, we're just redoing 4.1 again. The antiderivative of u is u squared over 2 minus the antiderivative of u to the minus 2 becomes u to the minus 1 over negative 1. You can make this a plus u here if you want. And then we just evaluate. Plug in or substitute in the upper limit, which is negative 1. Substitute in the lower limit over here, which is negative 2. Once you get those numerical values, okay, you should work this out to negative 2. So once again, I encourage you guys to work through all the examples and make sure that you're getting the same answers that I have on here. Okay, that'll really help you make sure that you understand what's going on and getting through the fundamental piece. Okay, let's take a look at this one here. This, if you remember from early on in section 4.3, we had a special integral here where we went from negative 3 to 3, or we went from negative a to a of that specific function. Well, what's going to happen here when we have this is we should be able to recognize this and see that it's going to cancel to 0. But let's go through the work here. It doesn't matter what variable as long as the dv and the v match, or x and dx, or y and dy, and those sort of things. Alright, so first step, find the antiderivative. So the antiderivative of v to the 1/3 is 3/4 v to the 4/3. I worked through all the steps there. You guys should be able to follow those. We're going to evaluate that from negative 3 to 3. Okay, so what happens is, when we have this negative 3 and 3 here, we're evaluating that same function, and then we're subtracting that function. So as long as the powers are even there, that's going to nix everything out. And when you evaluate both of these, we end up getting 0. Alright, another absolute value one. This one's real similar to your homework problem, so I wanted to throw this on here, and then I'm going to talk about the difference between this one and your homework problem. Okay, there's a slight variance between this one and your homework problem that we do. There might be like a function in front, or a constant sitting in front. Alright, so what you should automatically recognize is it's an absolute value function, so that you know that you're either going to have an upward pointing v or a downward pointing v. Okay, no negatives in front, so in this case we're going to have an upward pointing type v. Alright, you should be able to do the zeros for this one in your head, but if not, alright, know that negative 3 squared produces a 9, 9 minus 9 is 0, or a positive 3 squared produces a 9 minus 9, which is a 0. Regardless if we take the original function or the opposite. Okay? Now, a good way for you guys to do this, if you need to, is to look at the graph of this specific function. Okay? It'll really help you understand what's going on here when you put this in your calculator. So you got to be careful. If it was just x minus 9, then we would get our v. But it's x squared. So this function's a little bit different than the ones that you're used to. So I would graph this one in your calculator. Just wanted to reiterate here at the bottom of the notes how to put the absolute value in your calculator when you graph this. Absolute value, it's under the math function. So first, you're going to go to y equals, like you're going to graph it, so you're going to hit y equals, and then inside of y equals, you're going to hit math. You're going to go over to number, so you're going to hit math, hit over arrow once, number, and then select one. It's going to have like absolute value with a parentheses. You're going to select that one, and then you're going to type in the equation x squared plus 9, or I'm sorry, x squared minus 9. Then you're going to hit zoom 6. If it doesn't fit on your screen yet, hit zoom 0. It'll fit on your screen. You should be getting a graph similar to this one. I hand sketched this one, so it's going to look a little different. But the area, you should get this W looking type function. Notice the vertex of the V portions are at 3 and -3. Those are the roots of the function x squared minus 9 when it's in an absolute value term. Okay, so the area we're looking for is from 0 to 4 on the x-axis. So that's the part that I've shaded in. So notice we have to use two different integrals when we're doing the absolute value function here. We have to have the one that has the negative slope, and we have to have the one that has the positive slope. So our integral, if you basically look at this graph and understand this graph, is from 0 to 4 of the absolute value of x squared minus 9 dx. We're going to have the graph from 0 to 3, because you can see that's where the shaded region is, and we notice that that is the downward sloping part, so we have to use the negative there. So that's going to be the negative x squared minus 9 dx, plus if we go from 3 to 4, that's the positive portion of this absolute value function, so we're going to use x squared minus 9 there. Now it's back to basics. That's the hardest part, is being able to do this absolute value, okay, and breaking it into the two functions that we need it to, knowing where the roots are. So graph these, that will really help. Now it's just finding the antiderivative and evaluating. So we're going to take negative x cubed over 3 plus 9x. That's the antiderivative, okay, of the first one here. Notice I distributed that negative through, so that's why it's negative x squared minus 9. Okay, and then that becomes negative x squared plus 9, because that negative gets distributed through the parentheses there. Okay, and on the right hand side, from 3 to 4, okay, that antiderivative is x cubed over 3 minus 9x squared from 3 to 4. Substitute in the values. Okay, remember you got to do the upper limit minus the lower limit for each one of those. Alright, you should be able to follow that through and get 64/3. Okay, one difference between this problem and the problem that's on your homework assignment is a coefficient in front. Okay, so if I used example 11, which is the one we just worked through, from 0 to 4 of the absolute value of x squared minus 9 dx, say on your homework it's written as 0 to 4 of 3 times the absolute value of x squared minus 9 dx. What I would do, and what you should do, and what you're supposed to do, is factor that 3 out in the front. Notice that's the only difference we did. We pulled that 3 out in front of the integral. Then treat the integral the same way we just solved the problem. So work through all of it the same thing. Okay, and I'm not going to show all the steps here because we just did it. But we ended up getting 64/3, right? Then at the very end, once you've done all your integration, that 3 that you factored out in front sticks with you through all the work in front, and then we apply it. So 3 times 64/3 is 64, right? The 3's canceled. So essentially figure out the absolute value piece. Okay, you can factor that coefficient out in front of the integral, so do all of your integration, and then at the end multiply by that number that you factored out. That's really going to be the difference between your homework problem and the example problem that I just went through with you, is having a coefficient in the front. Alright, so that problem, that example we just went through, is going to help with questions 5 and 6 in your online homework assignment. So just wanted to give you guys a little bit of heads up on that one. Okay, next video we're going to continue on in 4.4, but we're going to get into doing some trig functions. So just want to break it up a little bit, give you guys a break, work through some of these sample problems, and give the ones that are similar to your homework problems a shot.